Welcome to our first virtual shop talk. Today we're going to do a quick demonstration followed by a little discussion on a small slab flattening jig. We're going to demonstrate it by flattening this piece of koa. Again, it's a very small slab, but there's no reason why this concept can't be expanded to do a much bigger one. As you can see, there's a very bad piece of punky material runs right along in here. That is going to come out once the slab is flattened. And then I plan to replace it with a strip of contrasting wood in a sort of a river edge type style. First thing I'm going to do is I'm going to use these shims to stabilize that. Then I'm going to take these blocks here, screw them into the particle board, and then into the edge of the slab. I was very careful to make sure that the size of these blocks are low enough so that once the screw is countersunk below the surface of this, there's no way in which the bit will be able to contact the head of the screw. One other thing I want to point out is that the edge here is not straight, so I can't butt this block up against here, screw it in, and then screw it here. It probably wouldn't even reach the piece of slab of koa. So what I'm going to do for this part here, just as a little added reinforcement, is I'm going to take this wedge and I'm going to put it in this direction. Then I'm going to put a second one in this direction to support this. The reason is you can see there's some flex in it even when this is stable. So I'm going to put this in to keep this middle part from flexing, but also I'm going to do it at the end after these are in place, because by putting this in, I can keep this piece here, this wedge, from moving out. Once the slab is stable on the particle board, the next step that I'm going to show in this segment here is that the piece of particle board will be butted up against these two bench dogs. And then I'm going to take a piece here between these bench dogs and the edge of the particle board and crank on it with the vise on the end here and stabilize the piece of particle board on the workbench. So now we'll have the koa securely mounted on the particle board and the particle board securely in place on the workbench. Okay, as you can see, I have the jig set up, and now I'll explain how it works. Essentially, these two runners are simply wood clamped to the edges of the bench. It rests on the edge of the bench, and it clamps using this 1/4-inch plywood that's attached to it. The top of each of these has been jointed so that they're good and straight. I simply clamp them in place and set the rest of the jig on it like so. It has a fence here, which if you push it against here and clamp it in place, will hold the jig to be true going across. In all honesty, I use this very small bowl routing bit, which only has about 1 inch in diameter. It requires a lot more passes across the slab, but I had it, and so I didn't bother buying a planing bit. Some of the planing bits are considerably bigger, and in those cases I would think that you would really want to be sure that you clamp it in each position as you move across. But you can take a bigger path at a time, a bigger swath across at a time. With this small bit, I find that the weight of the jig and just holding my hand in place is plenty to keep it from shifting on me and causing any problems. So I'm going to do that, but for safety's sake, I would recommend that you clamp it in place, particularly if you're using a bigger bit. So what it basically is happening is we start at one end, we work our way across, we do a swath, move it over by 3/4 of an inch and do another one, only because this is again, it's about a 1-inch diameter bit. If you have a bigger one, of course, your increments that you're moving it across the slab is going to be correspondingly bigger. Depth of cut is controlled by where you have the router set to plunge. And basically, I do a couple of fairly deep ones to start because, as you see, I'm not even getting it all the way across here. So once I get it close, then I do a fine pass or two as needed to true it up the rest of the way and give it a better, less tear out. That said, this is very little tear out really, because the bowl routing bit has rounded edges. You get a little bit of a scallop effect using it on here, which wouldn't be present with a true planing bit. It's not noticeable. You can see it, but it's not noticeable to touch really. So I found that with a simple random orbital sander, making some passes over it, I can very easily take care of eliminating that, and seems to work fine for me. A couple of things I'll point out. I have a stop block here at this end. You might be able to see it better if I get this out of the way. So basically it contacts the plate that the router's mounted to. And all it does is control how far back I can go. It prevents me from being able to go off the rails this way. But it also is adjusted so that the bit, which is right about here, is well clear of this piece. So I'm not going to back it into the side rail here. It's also back far enough so that it isn't going to contact anywhere on the edge of the slab. At the other end, I have one which I really only need to make sure that the bit will go past the furthest edge of the pad, the one that's the furthest that way, which would be right here. As long as I can get that, it's fine. I also want to make sure that I don't go so far that I hit this rail. So right now, this one is plenty good. It's just set up just right. As far as building this, these are dead simple. There's nothing really to tell about it. It's just, designed to ride on the ledge. But these are linear rails and bearings. The rails, of course, are these, and these blocks, 4 of them, are the bearings. I was able to buy these, 6 months ago on eBay for, I believe it was $39 for the whole set. Now I took a look and they run around $46. So you're still talking under 50 bucks. The rest of this, I had some angle aluminum that I made these brackets to hold the router plate up. The reason I wanted it lowered like that, I could have had it up here, but then I would have had to have more travel on my router bit to be able to make contact with the surface. This way I can go deeper without needing to resort to either lifting the slab or putting an extension bit in there, which I would prefer not to use if I don't have to. All of this, outside of the bearing and rail, all of this is stuff I had in the shop. This is an old router table plate, insert plate that I had laying around, and I just used it. You could use a piece of good heavy plexiglass or a piece of wood or what have you for doing this. There's no magic to it. What I'm going to do is I'm going to do a fairly deep, maybe a little less than 1/8 of an inch, but I'll do a pass over the whole thing, and then I'll come back and see where I'm at and whether I need, how many passes I need to make, how deep to make them, and so forth. Well, quite a difference. It's pretty flat. There are spots that you can see that the cut wasn't quite deep enough to contact everywhere. So I'll probably give this another very shallow pass, maybe, you know, a 1/16 of an inch or less, 32nd of an inch probably would do it. And then we'll be ready to take this off and flip it over and do the other side. This corner was clearly a little high, so what I did was I knocked that down. I'm going to lower the depth of cut, or increase the depth of cut slightly, and then begin to go through it again. Well, you can clearly see the two corners that it was rocking on were these two corners. And so as you can see by the pattern of what was cut here, what was machined away, these two corners were high. When you flip them over, those were the two corners that were touching, and I was shimming the other two corners. So we've just knocked down the uneven corners here. And now another pass, we can hopefully get this all clear. Might take two. Depends on how well I can estimate what depth I can do cleanly. One of the things I haven't talked about is a shortcoming of this jig, and that's dust control. On the positive side, what's being kicked up here are fairly good shavings as opposed to real fine dust in the air. I haven't felt the need to wear a mask. Maybe I should, but it's mainly because it's more bigger shavings hitting me and getting all over everything than it is fine particles in the air. If you build something like this, you might take it into account and come up with a better way than ignoring it. Second thing, the idea of these stop blocks here. If you are taking this idea and running with it, you might incorporate a T-track of some sort with an adjustable stop, maybe a cam lock type of thing, so that you could just slide it and lock it easily. It'd be a little easier than having these clamps hang off the way they do. The other thing I would mention is you can use these same rails for your lengthways axis too. They come in bigger sizes. These are 39 inches. They're actually 39.37 or something like that. They're 1,000 millimeter. But you can get them in longer sizes. Later on at the end of this, I'll talk about another possibility, another couple of things that you could do besides this idea. Let's just go ahead and make another pass. I've already got it set up a little deeper. Guessing we might need 2 passes yet, but we'll see where we're at. Okay, you can see that we need one more pass. We're getting most of it, but we've got a little section in the middle from about here to here. So I'd say at least one more pass. So here we go. That pass wasn't quite deep enough, but I didn't want to go any deeper on a single pass. But I've got just this little area right here that's still untouched. So I'm going to make one more pass. This time I'm going to start in here and make sure I've got a deep enough cut to clean this up. Then I'll go back and start over once I'm sure I'm getting complete contact all the way through. Okay, we are just about done here. I think this has come out quite well. It's flat, both sides. And we've got about 1.25 inches thickness left. No rock to it, solid, flat. Couple of comments, a couple of final thoughts. There are a lot of ways to do this. I've seen plans on the internet using the same kind of a rail idea for the length of the slab, but using a wooden trough, essentially like a long narrow drawer with a slot cut in the bottom and a piece of plywood or something like that that rides in that trough, that drawer, with the router mounted on it. And same thing, there are no bearings involved, but again, it works. Another way of doing it, I've built a number of things using this extruded aluminum. This is 1 inch by 1 inch. They sell it in different sizes depending on what kind of strength you need. But they also sell bearings for it. So I don't know, let's see if we can get a good view of this. But it's 3 sides are captured in the grooves here. And it slides very well, very smoothly. When you get these bearing blocks, they have pads of sort of like, almost like a thick tape thickness without the adhesive on it, that are designed with a slot in the middle, and you can slide them between the bearing and the aluminum frame of it over these screws. And each one gives you something like, I don't know, 5/1000ths of an inch. It takes up about that much. So you can put multiples of those in until you get just the fit you want. It can be very snug. There is no wobble to this, no flex to it. It's solid as can be. So this is another way to go. This, again, making one out of wood, depends on what wood you use. Doing what I did, like I said, I think you can do it for about, well, let's say under $50 for the linear rail and bearing sets on eBay. That's if you use the linear rails for the width of the slab and wooden rails for the length. You can do it for about that amount. These, I did a rough estimate, probably end up costing you a little over $300. So this is a much more pricey, but that is for a 8-foot, 3-inch tall. It's using the 1.5-inch tubing or extruded aluminum. So it's 1.5 inches wide and in multiples of 1.5 inches high. So it's 2 multiples high, so it's 3 inches. So 3 inches for your side rails and 1.5 inches square for your cross rails. And that'll cost you about, I want to say it was about $325 or so. Whether you use the idea that I used, whether you use a different one, whether you take my idea and improve it, there's lots of room for improvement, or whether you go with something like this. Give it some thought. You're responsible for your safety. So be smart about it. Make sure that your router is supported properly and isn't going to, you're not going to lose control of it in any way. Make sure that your rails are solid and it's not going to drop on you or what have you. Make sure that your slab it doesn't have wiggle in it and is firmly affixed to a workbench or a carrier piece like this or something like that. Give all of these things thoughts. Give dust collection thoughts. Go fancy, go simple, but go safely. So I think that's just about covering it. I'll kick this off now, and pretty soon we'll have a couple of minutes for some questions or comments. Thanks for watching.